How's that?
Good to go.
Okay. This will be a real short presentation. Um, I had hoped Damon would be here and help me co-present because he helped me with it, but I just got an email from him. I'm sorry I had to leave. I'm the only one here that can transport explosives, so I have to go. Take that for what it's worth. So, um, uh, not so much out away from urban areas, but here in fairly populated areas, we can see the need coming for more channels. Um, 2 gigahertz really isn't adequate. There's only one channel. It's 10 megahertz wide, which is okay, I guess, but kind of noisy from splatter. 3 gigahertz is going away. We have some grandfathering period, but it'll be gone in a couple years. 5 gigahertz works, but we believe they're going to allow an unlicensed overlay. Joe, we're secondary in that chat in that band. Is that correct?
That's correct. Our secondary allocation remains the same through the current action. It's just an increase of Wi-Fi unlicensed, taking away from the Department of Transportation for intelligent vehicle usage. That is both are currently primary, so they're just in essence arguing over who gets how much of it.
So the essential impact to us will be over time our uh, noise levels will go up in those areas.
That's correct, and that's always been the case. What we enjoy today, from one up to 184, 85, and down to the unlicensed Wi-Fi has always been allocated to the Department of Transportation, and it's just a matter of time before every vehicle on all the roads has is some wireless device in it trying to talk to every other car and bridge and anything that would impact safety of a vehicle would have these chip Wi-Fi devices and Wi-Fi like devices in them to communicate between vehicles and infrastructure to safely navigate. So that's always been at risk for us. It's just a question of when that will start being realized and deployed across all the roads in our environment. So this 5 gigahertz proposed rulemaking is saying, well, the Department of Transportation hasn't really used this, and the large commercial interests are trying to get it from them as well, and no doubt lobbying. And the FCC says, okay, well, you haven't used it. Let's just give half of it over, take it from the Department of Transportation and move it over to unlicensed Wi-Fi. There is expected to be some legal action on this that may stretch out because some of the Department of Transportation primary allocation was congressionally done. And so we just need to sit back and see how it plays out.
Well, thank you for clarifying that, Joe. It was never quite clear to me how that was going to work out. So at some point in the future, possibly it may impact our operations, but we just need to be aware of that. Going up in frequencies, 10 gigahertz is a ham radio band in the United States. My focus is United States. For my apologies for those who aren't US citizens. I'm fairly clueless about your allocations, so bear with me there. I did see something that the 2023 WARC is proposing a session on taking 10 gigs away from ham radio. We'll have to see where that goes. Above that, there is 11 gigahertz gear, but it's licensed. I don't know why I threw it in here, but not supported by OpenWRT, may never be. And there is no amateur radio allocation. The reason I mention it is we're starting to work with some local WISPs, wireless internet service providers. They're moving to 11 gigs more and more, and moving to 11 gigs more and more. And we're doing some back scratching, letting them have access to some of our sites, and they're letting us have access to some of their bandwidth between hilltops. So I just threw that in there. Above that, 24 gigahertz is a US amateur band. No Arden supported equipment. I'm not aware of any equipment there. And above that is 47 gigahertz, a US amateur band. Um, and there is 60 gigahertz. And the reason I mention this, it's unlicensed, but may or may not be supported by Arden. Whether it is or not, we could probably use it for short hauls where you don't have Ethernet. And I'll mention why they might need to be short haul. The range is severely limited by atmospheric absorption. And I'll talk about that in a bit. But the gear is relatively inexpensive. It's Microtech gear. They make a little bit higher end gear, but we're looking at some of the lower end gear. Joe believed that possibly their 60 here, the Microtech 60 gigahertz gear may be transverted down to one of the common boards as they support. We'll be investigating that. I want to talk about this for a bit. This was an eye opener. Over and above your attenuation through distance, RF is susceptible to attenuation through oxygen and water molecules. And you'll notice between 1 and 10 gigahertz, there really isn't much impact. But as you go up, I've labeled 24 gigahertz, not too bad, an additional 0.1 dB per kilometer attenuation for water. But if you look at the oxygen attenuation for 60 gigahertz, 10 dB per kilometer, that's pretty challenging. The reason I asked Joe to look at it, if we can implement 802.11n with narrower bandwidths than the default 802.11 AD that 60 gigahertz uses, which has, I think, 1.2 gigahertz wide channels, it's conceivable we may be able to get some more distance out of it rather than the default 800 meters. Anyway, something worth looking at. So maybe we can look at 10 gigahertz. The good things about it, it's a ham band, at least for now. Lots of bandwidth. Easy to get lots of gain. The cons, no existing gear supported by Arden. Power at 10 gigahertz beyond 1 watt is really expensive. We could probably do with 1 watt. Challenging to aim. I ballparked it, and at 10 gigahertz, if we're using a satellite TV dish, the beam width is about 2.7 degrees. So, but then if you're going to use it in a fixed installation, you aim it once and you're done. And again, this would not be for users. This would be hilltop to hilltop, maybe to replace some of those increasingly noisy 5 gigahertz links. We'll see. This is future stuff. It would be relatively expensive to deploy because we have to make it. The way we get there is a 5 gigahertz transverter. Drive it by a Ubiquiti rocket. Mount it at the feed point of a surplus satellite TV dish. We'd have to design it and build it. We'd have to fund that. And you need 2 per site for MIMO. This is sort of a just ballpark blue sky diagram. Damon said he had resources to design and I think build the feed horn, which is a good thing. And this is kind of like a implementation concept. He did say the the feed lines have to be pretty short on the 10 gigahertz link between the transverters and the feed horn, and because of losses, obviously. Need to find a microwave designer. Damon knows a couple of them, and they kind of turned up their nose at it. Implied it would be difficult. Get through the design development, prototype stage, not just the boards, housing and a power feed, and a dual polarization horn for the dish feed, and then figure out a production run and funding. But in thinking about it, if we could make this work, it's not just Arden. Hamwan might like to chip in, and a number of the large repeater systems are using microwave digital linking between their sites more and more for DMR and the like. So we might be able to find funding. Ballpark costs, development boards, Damon said a minimum of $800 per, well, not Damon, Ham, who builds 10 gigahertz gear, said typically the boards he's had prototyped were 800 bucks a piece. And he said typically it took him 3 iterations to get it right. So you're saying several $1,000s at least. Production run, satellite dish, nothing. Rockets, not too bad. The guy I talked to said if you make a moderately large production run, you could probably get the transverter boards down to $100 each. Again, that's just a guesstimate. And feed horn, got to talk to Damon about that. This is on the power feed too. If they can run off 24 volts, I was thinking in the little housing at the bottom of a rocket that you can remove and where you connect the RJ45 cable, there's enough room for a small power tap-off board if it's 24 volts, or even a down converter if it wants to run on 12 or something like that. But that would have to be designed and built. So in the distant future, if we do lose 10 gigahertz, transfer to 24 gigahertz, eesh, or transfer to 47, eesh. So anyway, just some thoughts for the future. This is not near term or anything. This is just some ideas of where we might go. And this has nothing to do with the presentation, but one of the local hams said to mention Mattermost. The Arden development team uses a Slack channel for their development, and that's fine. Locally here, we run a Mattermost server. It's a chat server, works very, very well. Eric KG6WXC set it up on our mesh network and we use it. But additionally, he set up another instance on the internet and the two talk to each other. So if you'd like to chat Arden with us real time, drop me a note and we'll get you invited. You can log into the internet instance and talk to 75 or 100 people who have accounts there. There are between a dozen and a half a dozen people who hang out 24/7, and others check in and out, and it's fairly handy. I doubt if there will be any. Let's see. There's a question. Joe, there's a question about the Arden gear.
Okay.
Time division multipliers. Yeah, go ahead.
Okay, so this is the driver for 802.11n in Arden is open source. It's called the ATH9K driver. That's 802.11n, and there's an ATH10K driver for 802.11ac. In those drivers, the specification is a carrier sense multiple access protocol. So we're following the specification in that regard. Now, like Ubiquiti, the timing, instead of being a carrier sense multiple access, would do a time division to assign slots to different stations. But in terms of what has to happen, it has to fit within the 802.11 specification on how the timing works and what I described earlier as the OFDM signal itself, which is frequency division multiplexing. So there's no other option in 802.11 except frequency division multiplexing or those multiple carrier waves to meet the specification. I hope that answered it.
Okay, so I'm going to shut off the recording for now and thank you all.
I have a